we're going to be using the Pythagorean identities for trigonometry for quite some time. And it's important that you get so good at these things that they just start appearing when you look at them, and it doesn't even take that much work. Because when we get into more complicated trig equations and trig proofs later on in this quarter, you're going to want to know these formulas so well that you can't forget them. So what I want to do is first highlight our main tools in this problem. These are the Pythagorean identities. And you see right off the bat, two of them are not really that useful. The tangent and cotangent ones, these guys, those are useful in other situations, but if you look over here on the left, nothing here involves tangent and cotangents. Okay, so that's great. We can kind of ignore those for the time being. And our main workhorse is going to be this guy right here, the Santa Claus identity. And you see that has two other ways we could write it in terms of sine squared equals 1 minus cos squared and cos squared equals 1 minus sine squared. Now, that right there gives you one of the first clues you need. You see right here, choice A, 1 minus sine squared. That matches up with cosine squared. So that's an easy one, right? And likewise, 1 minus cosine squared, that matches up with sine squared. Okay, so we've got some very low-hanging fruit right there. That doesn't even require a whole lot of thinking. But there are a few other things in here that might not be so obvious. So I'm going to go down the list on the right side, and we're going to focus on one of these things at a time. So if I look at sine plus cosine inside of parentheses and squared, there's no quick way to do that one. Instead, let's just FOIL it out and see what we get. Sine theta plus cos theta squared means sine theta plus cos theta times sine theta plus cos theta. So we're going to do FOILing now, which is going to lead you to sine squared cos theta plus, I'm going to skip a few steps here. This is going to be 2 sine theta cos theta, and then plus cosine squared theta. If you're not seeing that, write it out yourself for 10 seconds and you'll see how all the terms match up. Now, hopefully you can see something here at this point, and if not, don't worry, you'll get practice at it. Remember that sine squared plus cosine squared equals 1? Look what I have here, sine squared and cosine squared. So that means this turns into 1 plus 2 sine theta cos theta. Okay? Now, is that over here on the left? Yep, right there. Okay, so that's how you do some of this stuff. The low-hanging fruit is easy, but most of the time you'll have to do some algebra to find the matches. Okay, so let me clean this up a little bit, and we're going to go attack the third one, just so you can get another example of how this works. So if I say 1 minus sine with a squared on it, that's going to turn into 1 minus 2 sine theta plus sine squared theta. Now, is that over there on the left? I don't think so. I don't think that one's actually over there on the left. Okay, so sometimes it doesn't quite work like this, or maybe I'm missing something. Oh, wait, no, I am missing it. I just didn't see it. 1 minus 2 sine theta plus sine squared. There it is. Okay, so it is a bit of a lengthy list. You might have to work through it. I'm not going to go through this whole thing and show you how to solve every single one of them, but I want to focus on one that sometimes causes some problems when people are doing this, which is this sine to the fourth minus cos to the fourth. Because when you're starting this out, you might look at this and think to yourself, I don't have any fourth power trig identities. We only have squared power trig identities. Well, let's use a little factoring. So I'm going to put sine to the fourth theta minus cos to the fourth theta right there. And let's try to think about this as a u substitution problem, where I've got basically a squared minus b squared. Well, what's a? A is equal to sine squared. And what's b? B is equal to cosine squared. And if you remember what this factors to, remember a minus b, a plus b. That's the difference of squares right there. So now you can use these substitutions, these sort of u substitution trick type things, and plug them in there, and you'll see that this actually becomes something a little more straightforward. It turns into sine squared minus cos squared times sine squared plus cos squared. I said it would be more straightforward. Maybe it's not quite straightforward yet, but there's one more trick you can use to simplify this thing at the end here. That can be written easier than it's written right now. And what you'll find as you work through these is some of these examples over here on the right side, some of these formulas, actually may point to multiple problems on the left.